What is electroplating? So we're looking at some uses of electrolysis, and the first one is electroplating. Okay, so electroplating is the process which uses electrolysis to plate or coat one metal with another metal. So we're going to be coating it with another metal. That is what electroplating is, coating one metal with another metal using electrolysis. So now, why is this done? Why is electroplating done? It's done to protect objects against corrosion. Okay, because corrosion is going to wear away that substance. So we want to protect it. And another thing is to make it more attractive. Okay, when we electroplate, we make it more attractive. Look how shiny these look. How is electroplating done? So electrodes. So at our cathode, we're going to have whatever object that you want to be plated, you're going to have that at the cathode. And at the anode, you're going to have the pure silver. So let's look here. You have the pure silver at the anode. And at the cathode, you're going to have whatever object it is you want to plate, you're going to have it at the cathode. Whatever object you want to plate, you're going to have it at the cathode. So the next thing is the electrolyte. The electrolyte for plating with silver is always going to be the silver nitrate. It's always going to be silver nitrate, people. Next, what are the ions present? The ions present, of course, would be the ions present in the electrolyte, which is the silver and the nitrate. But also, you have your H plus and you have your OH negative because it's water is also present. So some of you might be asking, so why do you have NO3? Why did you split it up? Because NO3 is a polyatomic ion. If we split it up, it's no longer nitrate. So the ions at the cathode, of course, is now going to be the positive ions, and the positive ions are going to be your silver and your hydrogen, and your anode are going to be your nitrate and your OH negative. Okay, remember now you have to put the charges. You have to put the plus charges and you have to put the negative charges, or else they are not ions and you can't get your point. So now the anode reaction. At the anode, I want you to look and see what actually is happening at the anode. Alright, the anode reaction, remember, is a negative reaction, right? Because this is the reaction where you have the anion losing electron, right? So at our anode, what's going to happen is the Ag silver, alright, the atom is going to become the ion. You're going to have the Ag silver, which is your strong silver metal becoming an ion. So Ag silver minus an electron is going to be giving you Ag plus. Alright? Because we want to be losing the electron. Because the electron needs to be lost in order for it to go to the object. So here we're going to have the pure silver is going to lose an electron to become the silver ion. So what do you think is going to happen at the cathode? Yeah, the cathode needs to be receiving that electron. Okay, so at the cathode now you're going to have the CmAg plus, all right, CmAg plus here that you have being produced at the anode. That CmAg plus is going to be CmAg plus. We're going to add an electron to it, and it's going to give us that pure silver. All right, so Ag plus plus the electron is going to give us the pure silver. All right, that's it. So now I want you to label for me the anode, the cathode, and the electrolyte. We know that the first one we have is the anode, yes, the pure silver is the anode, and then the spoon will be the cathode. Very good, you have your battery. And then what was the name of the electrolyte? Silver nitrate. It's always silver nitrate. Good job. So do you remember the anode and the cathode reaction? You need to. At the anode, you have Ag, solid, remember, is losing that electron to give you Ag plus. All right. And then you're going to have the reverse is going to be the cathode reaction, which is the Ag plus the electron is going to give you silver. Good job. Give yourself a pat.
Finding of copper. Take an electrolyte of acidified copper sulfate solution. Take the anode as a thick rod of impure copper and the cathode as a thin rod of pure copper.
Oh, there are so many people here. Hey, give me my jacket.
Ew.
Current is passed through the solution. As a result, the acidified copper sulfate electrolytic solution splits into copper ions and sulfate ions. The copper ions from the electrolyte get attracted towards the cathode. The copper ions gain 2 electrons from the cathode. And deposit as pure copper atoms on the thin copper rod. At the same time, copper atoms from the anode lose 2 electrons, get converted into copper ions, and dissolve in the electrolytic solution. Thus, the concentration of the electrolyte remains the same. In this way, indirectly, copper atoms from the anode get deposited on the cathode repeatedly.
Alright, so the purification of copper and another video helped you to get a better understanding of what exactly this is all about. Alright, so we have the electrodes, and now we have the electrodes. They are made up of copper, not carbon this time, copper. And the pure copper is at the cathode, see? And then the impure copper is at the anode. Alright, good job. Also look at the electrolyte. The electrolyte is this, what's the name of the electrolyte? Copper 2 sulfate, and what color is it? It is blue. So at the beginning of electrolysis, copper 2 sulfate is blue in color. Alright. And I also want you to notice the anode. I want you to look at the anode, and I want you to look at the cathode. Look at the sizes, because that's very important. So now we have the purification of copper, and there's a lot of things going on. The first thing I want you to see is this thing right here that's at the bottom of the anode. We call it the anode mud, alright? It's impurities, okay? Also known as slimes. The next thing I want you to notice is the ions that are present in the solution. We know that the ions are going to be that of the ones in the electrolyte, but also which of the 2 ions are present? H plus and OH negative. Thank you. Next thing I want you to notice is what's happening at the anode. Alright, look at the anode and look at the cathode. Alright, so the anode contains the impure metal, and what I want you to note is that what's going to happen is the anode, remember we have the negative reaction at the anode, and it is for this reason that we have the impure metal there, so that the impure metal could lose some of that dirty electron that it has there. Okay, so what we have is the impure anode loses electron and it becomes the copper ion. So what's the reaction? You're going to have copper solid. Alright, if we remove 2 electrons from it, you're going to have copper plus 2. So this is a negative reaction that's going to be happening at the anode. And yeah, so copper now is going to be deposited. So the copper that was produced here is going to be deposited at the cathode. So what's the reaction going to happen like? Okay, again, the reverse reaction is going to happen. Alright, so copper ions are going to become copper atoms. Copper ions are going to become copper atoms. So you're going to have Cu plus 2 here. And then, of course, if you have plus 2 here, you have to repeat the plus 2, E, and then you have copper solid. That's it. So the color of the electrolyte, we know that the copper sulfate is blue. However, the blue color disappears and the solution becomes colorless. Why is this? This is because copper is produced at the cathode. All right. So the copper ions in the solution, they're being used up. They're being used up, causing the blue color to fade. So because the blue copper is being used up, all right, we're no longer gonna have a blue. Our solution is no longer gonna be blue. It's going to be colorless. Now we have another use of electrolysis, which is anodizing, and we see this in our pots. So aluminum does not show its reactivity right away because it is protected by a thin oxide coating. So this is why aluminum is not reactive. It is because of this oxygen layer that it has coating it. All right. This thin oxide layer, however, we could make it thicker. The oxygen layer is thin, but we could make it thicker by anodizing. So anodizing, it thickens the oxygen layer found within the aluminum. And this oxide layer allows for colors to be absorbed well, and it gives pots and statues colorful finishes. If you want that nice finish, you're going to have to anodize that pot. Okay, and anodizing is just when you thicken that oxide layer. So here we have a question. So impure copper is extracted from the ore using copper smelter. Using the process of electrolysis, the impure copper obtained from the smelting process can be purified. What is the name of the material of the found at the anode? Because at the anode it was impure copper. Good job. At the cathode we had pure copper. Yes. The solution that can be used was copper 2 sulfate. All right. Good job. I asked you what type of reaction occurs at the cathode. Reduction. State the color of the electrolyte at the end process. We know that it is colorless, right? Good job.